Let's try again, but I appreciate the honor. What's 207 plus 10?
Bro, who says he's right side of your?
Now, what do you have to do? What do you have to do? Divide by 7, okay. Have you ever been taught shortcut division? All right, 7 goes into 21. How many times? 3. How many are left over? 7 goes into 7. How many times?
1. Oh my God. Bro. How do you know?
That's what I call them.
I'm more of a lattice kind of guy myself.
Lattice will get you nowhere. You want to bet? All right. I will tell you one thing. Lattice will get you nowhere with fractions. Lattice will get you nowhere with trig functions. Lattice will get you nowhere with polynomials. It won't get you anywhere. You got to know how to. You got to go back and revisit this. So again, as I'm saying, you should be able to do that. Okay. Now, what do you have to do next? All right. So, what do you think square root of 31 is?
Plus or minus square.
There you go. Okay. I always make sure to leave you guys with values that you should be able to figure out. Okay. 31, obviously, that's just 1 and 31. It's obviously. Now, I try to stay away from overly large numbers to have to figure out square roots, but usually if you know how to check with your perfect squares, see if it's divisible by 4, see if it's divisible by 9, usually then it falls into place after that. Okay. Break it up into primes like you have been done in the past. Let's see the other one that's here. Let's flip around and go to 27, why not? Okay. So, one of the things that you guys probably remember now, I always just switch back to X for my variables. Like I said, these worksheets and stuff, they always tend to repopulate variables. No big deal, it all means the same. So, what's your first step to do when you have to solve for your zeros? What? Z equals 0. So I'll move everything over to the left. So we have 5x squared. What is that? Minus 41 plus 42. Okay. So now we have to multiply our tails. Now, when you multiply your tails out here, you've got 5 times 42. Well, once again, this is something we should be able to do. So I believe that's what, 210? Yeah. Okay. So what you're looking at is what times what is a positive 210, but when you add them together, you get negative 41. Now, the reason why I wanted to show something like this that was a little bit larger to start with was so that way you can kind of start to see how you can guesstimate where it goes. We know that 5 and 42 multiply to 210. We know that. So now what we need to do is just kind of manipulate and see what else can we get to. So 210 is divisible by 7, correct? Okay. So if I did 7, that's 7 and 30. That's not going to work. Okay. I can try. What would it be? If I know it's divisible by 30, I know it's divisible by what? By 15. So if it was 15, wouldn't that be? If that was half here, wouldn't that be 14 here?
Yeah.
Okay, so let's go in the wrong direction. So we're just doing a little guess and then check here. So let's try to see if 6 works. Okay, if 6 would work, let's see, that would be what? 3 times 6 is 18. 18 and 31 to 35. Oh, and there you go. You're trying to see what values can end into 0. You're just kind of bouncing around by checking a couple of easy numbers. Okay, so that gives me my 41, doesn't it? Because both of them can be negative. The reason that they both had a negative is because the last one was positive. So Even though it took an extra second to figure out and fish around for it, we found it. 5x squared minus 35x minus 6x plus 42 is 0. Refactor this via grouping. So we group the first two terms. What's the GCF of the 5x squared and 35x?
5x.
5x, good. So I'm going to take out a 5x. Inside the parentheses, I'm left with x minus 7. Third term is negative, so what should I do real quick? Plus a negative. Plus a negative, good. The reason we do this always is so that we remind ourselves that you have to take the negative out. So, GCF of a 6 and a 42. Okay. Take out the negative 6, and inside the parentheses, lo and behold, you're left with x minus 7. That's a pretty good sign. So, that means that one term is x minus 7, the other term is 5x minus 6. And then since this was a calculate 0, to get my zeros now are just set both of those terms equal to 0, and hopefully by now you guys realize that, hey, it's 7 and 6/5. Add 6 divided by 5. Okay. Not terrible? Just want to remind you, when you're looking at those larger values, it's okay that it takes a second to find it, but it's not anything that shouldn't be too crazy. Okay? Let's see. This one isn't on there, but I know we had one like this in the homework. I don't think you guys ever asked about it though. This isn't on the sheet here, so you might want to just add this real quick. I think this was one of the homework problems we had last week. I think this was from Thursday. Something very similar to that. This, like I said, this is not on there. And this was a homework one from last week, so that's why I wanted to make sure you guys saw something. So I don't think you guys ever asked about it. When you have this, you've got junk squared on one side. That means it's wanting you to take a square root of both sides to get rid of it. So, what should you do first? Nope, can't do that.
All denominators.
You multiply all the denominators by 3, you're still going to have a denominator. Subtract what? Yeah, subtract the 6. Subtract the 6, you get x minus 1 quantity squared over 3 is 4/6. Okay?
2/3.
Which is, like you said, how much?
2/3.
2/3. So we know that this is now 2/3. So how do I undo divide by 3? Those go away. Those go away. You wind up with x minus 1. Quantity squared is 2. Now what do you do? Square root it. When you take a square root over an equal sign, what do you always have to write? Can I simplify the square root of 2?
No.
Nope. And then lastly, I write it out with x is 1 plus or minus root 2. Remember, always put your constant values in front of the plus minus. It's just more of the mathematical way of doing things. We just haven't seen one like that in a while. I want to make sure I revisit that real quick. Not necessarily, I just knew that was...
Skill check right now.
Let's go back to number 2. So this case here, it's axis of symmetry, vertex, a couple sets of symmetric twins, things like that. What form is that in? Standard. When you're in standard form, you do A, B, and C. Our A value, A, B, and C in this case are -2, negative 20, and negative 56 respectively. And then you have to, after you do that, the first thing you do then is find your axis of symmetry. Your axis of symmetry for standard form. X equals the opposite of b over 2a. I heard you mentioning it. So opposite of a negative 20 is, bless you, positive 20. Excuse me. Then it's 2 times negative 2. So my axis of symmetry is at x equals negative 5. Vertex, bless you. Is vertex up like a cup, or excuse me, is this graph up like a cup or down like a crown? Why is that? A is negative, good, so I forgot to put that there. So will that vertex be a maximum or a minimum? Maximum, good. So axis of symmetry. It's at x equals negative 5. We know the vertex has an x coordinate at negative 5. Okay. The downfall of this problem is that the values of the rest of the problem are kind of large. But you're only able to find by negative 5, so it's not terrible. So, what's negative 5 squared? 25. 25 times negative 2. So we're at negative 50 for the first part. Negative 20 times negative 5 is positive 100. And then subtract 56. So, negative 50 to 100 is 50. Subtract 56, you're at? So, even though it looked like it was going to be awful, it's nice when the numbers work pseudo-clean. So that places you at negative 5, negative 6. You know that it's moving downward. It asks you for 2 sets of symmetric twins. When you have sets of symmetric twins, we have our vertex, negative 5 and negative 6. I would generally just pick the next closest value, but in this case, bless you, since it's in standard form, we know the y-intercept, don't we? The y-intercept is down here at negative 56. How far away is that y-intercept from your axis of symmetry? It's 5 away, right? So at 0, it's negative 56, which means on the other side of the axis of symmetry would be what? Negative 10, good. So use that form, that standard form, to your advantage to find those values. Okay? Does that make sense? Now, would I use negative 4 and do all that multiplying, or would I use negative 1? Absolutely. Make it easier on yourself. Okay? Make it easier on yourself. If I use negative 1, first term becomes negative 2, bless you. Negative 1 here becomes plus 20, and then minus 56. So once again, you're playing around with values that make it easier to math on your own. Utilize standard form to help you. Okay? So this would be negative 36, subtracting negative 38. Sure. So at negative 1, negative 38, which means then on the other side it would have been what, at negative 9?
Yes.
And you're done.
Whoa.
Does that vaguely ring a bell?
Yeah. So, but like for the graph that you gave us, just like draw the points.
I wouldn't give you a graph. It just, when I press the buttons, it just the spacing is just generated. So obviously here you wouldn't be able to fit it on the sheet, so no big deal. You want to do an intercept form or vertex form? Intercept? All right. So let's look at 6. So, excuse me. We're going to do an intercept form. When you have intercept form, that means right off the bat you know zeros. You know your zeros right away. So here we have zeros at 1 and negative 2. Okay? Are we okay with that? Now, the A value is a positive 3, so will this be up like a cup or down like a front? It's going to be up like a cup. Good. We also know that if I add those two zeros together, so what's negative 2 plus 1? And then our axis of symmetry, when you divide it by 2, you get negative 1/2 for your axis of symmetry. Okay. So our axis of symmetry is the halfway point of those two values. So our vertex will be at negative 1/2 comma something. Well, what's negative 1/2 subtract 1? Negative 1/2, right? So I'm going to write that as negative 3/2. Okay? Negative 1/2 plus 2 would be positive 3/2. We okay with that? Now, the reason why I write things out in fraction form is because it's easier to multiply fractions than it is decimals. What's 3 times negative 3? Times 3. What's 2 times 2? Now that's what? A little bit less than 7? Negative 7? Okay, sounds good. So it's down here. Now, when you have when you have your vertex and your two zeros, that means you only have to find one more set of points, don't you? What's going to be the really easy number to pick?
0.
0. If I pick 0, 0 is 1/2 away from my axis of symmetry, which means the other one would be at negative 1. So I know then I can find something at 0, and then I can find something at negative 1. But I only have to math one of them because multiplying or adding in 0 here is going to be really quick. So what's 0 minus 1? Negative 1. What is 0 plus 2? 2. So what is 3 times 2? Times negative 1. There you go. Okay. Utilize the forms to make your lives easier. Okay. Anytime you can pick and get something close to a 0, or excuse me, the y-intercept, go for it. All right. You could have looked at this problem and done your y-intercept right away. If I just covered up x, 3 times negative 1 times 2 is my y-intercept. There's no way of doing it. Okay. Word problem stuff, like I said, they're not going to be anything different than what you guys had done on that previous packet stuff. What I'll do is, I think I have a copy of mine that I had fully worked out. So I will finish working that through, and I'll have it posted either by the end of the day today, or have it posted tomorrow morning. So that way you guys can look at the solutions for all the word problem stuff that we did. So you can just, if you want to double check your work, go through there. And kind of go up. Any other ones in particular? 15? Oh, sure. So in 15, you're just multiplying straight across. So when you're multiplying straight across, you've got negative 7i times 6i times 8 minus I. When you're multiplying, the order doesn't matter. What I would do is multiply these two guys together first, and I would get negative 42i squared. And I squared is what? It's negative 1. So this becomes negative 42 times negative 1, which is 42. And then I distribute one more time. When I distribute that, let's see, bring an 8 here, I get 16, 32, 33. It's just multiplying.
Oh, wait, I see.
Multiply 42 times 8. I have to distribute in, so 42 times 8, I just wrote it differently so I can multiply it easier. Okay. That helps. Anytime you have those, break them in small parts. You especially get two constants with the eyes, because it's just the eyes are
I'm exhausted.
I'm sorry, I'll just take tomorrow off.
Thanks.
You're welcome, guys. Not you. You are right. You make it. Here's that dinner charge. Sure not. Who else did you hear? I mean, you are any other juice? Okay. Do you still have your old multi-view from last year? Bring that calculator too. There's no rule that says you can't have two of them. That way, if you have to simplify square roots, you can do it real quick. If it's faster, if you're going that route. So there is calculator, non-calculator on the SAT as well. So, good fun. Yeah. Did you guys have a word problem you want? Did you have a word problem that you guys wanted to look at real quick, or you okay, or? Did you guys have a nice long weekend? You did what? Nice. I planted a dozen spruce trees yesterday. I'm tired. What's that? Yeah. They were about 3 foot. So. What?
Did you grow them up in Bowmanville?
No, I did not grow them myself. I went to Lowe's. They were half off, so we bought a bunch. Little spruce tree bushes. I mean, they're dwarf ones. They're only gonna be like 6 foot, but it'll look really nice on my plants. No, it's only 6 foot. Well, yeah, there we go. So 6 foot to me isn't that bad. That's all. Then I went fishing. Caught a big fish. What's that? Good times. Kid was sick. And he went and played soccer on Saturday. We only had, on Saturday, our game was at Oh, yeah. We played out off Airport Road, Sycamore out there, and same thing, it's just wide open. It was crazy. The kids had a blast. Our coach, no call, no show. Didn't bother to show up. We weren't upset. There's 3 races.